Hello everybody, today we're going to talk about surface areas of pyramids. So we did other shapes the other day. Pyramids are pretty much the same. The only difference is you're going to deal with a bunch of triangles. So a pyramid can be drawn as a net, just like a prism can, except all it is whatever the shape of the base is. In this case it's a square, so here's my square, and then it's surrounded by a bunch of triangles. Okay, so you're going to have to know the triangle area formula for sure, and then be able to find either the area of a rectangle or a square, parallelogram, whatever the base could be, you're going to have to be able to find the area of that. So here I've taken this square pyramid right here, and I've drawn it as a net, and so we're going to find the surface area of this pyramid right here. So here's what I know is this square right here is 12 on this side, which means that since it's a square, it's 12 on all the sides. So the surface area is going to be 12 times 12. Now, this particular net has 4 identical triangles, and you got to make sure they're identical before you do this. So if they're not identical, then you got to do them each separate, but I'm going to do them all at once. So remember, the area of a triangle is 1/2 the base times the height. Well, the base of the triangle is here, that's 12, and the height is 14. So we've got the area of the base of the pyramid, and then we've got 4 times the area of the triangles, because they're all identical. Okay, so then that means that the surface area is 144 plus. Now the 4 and the 1/2 are going to cancel and leave a 2. So let's see, 14 times 12. That's going to be 168 times 2. That's going to be 336. And 68 times 2. Yeah, 336. Okay, and so then we just add those together, and we get what? 480, and that is in square centimeters. And we're done. There's a surface area. So pretty simple to do. So I'm going to let you do these. Take a second and find the surface area of those. And then jump back on here and make sure you got them right. Okay, this one here, we're going to have a square that's 4 by 4, and then we're going to have 4 triangles that have a base of 4 and a height of 9. So the surface area, you can draw this as a net or not, it doesn't matter. And if I was going to draw it as a net, it would look like this. Okay, definitely not perfect, but good enough. This is 4 by 4, and this is 9 right here. So, so the surface area is going to be 4 times 4 for the base, plus 4 identical triangles, half the base, which is 4, times the height of the triangle is 9. So then, let's see here. This is going to be 16, plus that's going to cancel and make a 2. So it's 36 times 2 is 72. And then that's going to be 88. And my units are going to be square centimeters. So you should have got 88 square centimeters on that one. Now this one's a little tougher because the numbers are bigger. That's the only reason. So on this one, it's going to go the same way as the other one. It's got 4 identical triangles. It's got a base that's 345 by 345. Plus 4 times half the base, which is 345. And this is the base of the triangle this time, times the height of the triangle is 255. Okay, I'm going to need a calculator for this one. So 345 times 345. Oops, somehow I got an error here. 345 times 345. This is 119,025 right here. Plus, again, those are going to cancel and make a 2. So this is going to be 2 times 345 times 255. This is 175,950. And now I just have to add those two things together, so plus 119,025, and my surface area comes out to be 294,975 square meters. Very, very large pyramid. Okay, so hopefully you got both of those correct. And let's do this one. Now this one's slightly different because the base of this thing is a triangle. Now, this is called a tetrahedron, which means 4 faces essentially. Now a lot of times the tetrahedron is really simple because all 4 faces are identical triangles, but this one is not. So this one has got 3 identical ones around the sides. That's the lateral faces, and then the base is a little bit different. That's the one that's got a different height. So otherwise we're going to do it exactly the same. So we're going to start out here, we're going to say the surface area is going to be the base. Now the base, let's just do this. Let's get our highlighter. There's the base. Okay, so the base is going to be 1/2, and this is, when I say base here, this is capital B because it's an area of a base, is half the triangle's base, which would be 6.93, times the height of that triangle, which is going to be 12 inches. Plus, now I've got 3 identical, and I have to, it doesn't say they're identical, but I don't have any other information, so I have to assume that they're identical. So 3 times, again, triangles, half of the base of this triangle, which is 6.93, times its height, which is 18 inches. Okay, definitely a calculator question here. So, here we go. 0.5 times 6.93 times 12. This is 41.58. And then we have 3 times 0.5 times 6.93 times 18. 187.11. I want to double check that. That seems awfully light to me. 12 times 6.93 times 0.5. Yep, okay. So now we just got to add those together. Plus 187.11. That's 228.69 square inches. So you have to look at the base of any shape, really. It could be different. And you could even get something like this. I could give you a pentagonal pyramid, like so. Okay, and then you'd have 5, and probably they're going to be 5 identical triangles, but the base down here is a pentagon, and we've never really had a formula for a pentagon, but I could just say, hey, the area of the base is, I don't know, 15 square inches, and then give you information to calculate the triangles, and then you'd add up the 5 triangles and just add the 15 on the end, and then you'd have that pyramid. So, anyway, there you go. Okay, so we're going to do 1 through 19 odd in class, and I'll talk to you guys later.